So welcome back. We're going to take a little quick sidebar. We're going to talk about multiplying using the rectangle model. Some of us call that the distributive property. So what I want to do is use a rectangle as a way to organize multiplication problems. One thing about rectangles, we know that the area of a rectangle is length times width. Or in other words, L equals LW, it's for short. A lot of times area equals length times width. So what we learned is if I want to know how many squares are inside of a rectangle, what I can do is multiply the two sides together and that'll be the answer. So for instance, if I had 5 times 6, again, if I want to know what the area of the rectangle is, the area means how many squares are inside there. Well, if it's 5 tall, that means it's got 5 squares tall. And if it's 6 across, it means it's 6 squares across. And those are supposed to be equal squares. Gotta forgive my artwork there, but so what we're asked to find out is how many squares are inside there. So if you look, there's like 5, 10, 15, 20, 25, 30. So there's 6 rows of 5. We also learned that instead of saying 5 plus 5 plus 5 plus 5 plus 5, we also could simply say 5 times 6 there. So that's our shortcut for that problem. So 5 times 6 could give me my 30. So if I want to do 5 times 12, what's interesting is I can actually change 12 into 2 pieces. Because there's 2 numbers that I would add to get a 12. I can add a 10 and a 2, and that could give me 12. In other words, I could break the 12 apart based on its place value. So there's 1 10 and 2 1s, or 10 plus 2. So what I can do is, instead of using one big rectangle, I can still say this is 5, but I can partition it off into 2 small rectangles. So 5 times 10 would represent the area of the bigger rectangle, and 5 times 2 would represent the area of the small rectangle, and then 50 plus 10 would be my total area of 60. So in other words, if I come over here, I'm allowed to distribute the 5 through the problem. 5 times 10, and then 5 times 2, and 5 times 10 is 60, and 5 times 2 is 10, and 60 plus 10, 5 times 10 is 50. 50 plus 10 is then in turn 60. When I model like that, when I multiply through addition, that's referring to the distributive property. So if I look at 12 times 13, another way to look at 12 is 10 plus 2. Another way to look at 13 is 10 plus 3. So I can partition this off into a 10 and a 2, and a 10 and a 3. So what I end up doing is partition this off into 4 small rectangles. So 10 times 10 would be the area of this rectangle. 10 times 3 would be the area of that rectangle. 2 times 10 is 20, and 2 times 3 is 6. So 100, 130, 150, 156 would be my result. So if you can kind of see here, you're actually doing the distributive property twice. 10 times 2 is 100. 10 times 3 is 30. 2 times 10 is 20. 2 times 3 is 6. And there's your 156. Now, some people call this FOIL when you do that kind of problem. First, outer, inner, last. So it's the FOIL method, or more commonly known as distributive property. Now, if I look at 59 or 49 times 21, what I could also look at this problem as, instead of saying 40 plus 9, I could think of that as 50 take away 1. Because 50 take away a 1 is still going to be 49, and 21 is still 20 and a 1. So I can get kind of abstract with this, because you really can't have a negative link. This now becomes truly just a model of organization, because it doesn't really represent a rectangle anymore, because you can't have a negative side for rectangles. So 50 negative 1, I have a 20 and a 1. And then I would have 1,000, 50, negative 20, and a negative 1. So you'd have 1,050, take away 20 would be 1,030, and take away a 1 would be 1,029. Or if you used your FOIL method, distributive property, 50 times 20 is 1,000, 50 times 1 is 50, negative 1 times 20 is negative 20, and negative 1 times 1 is negative 1. So you'd have 1,050, 1,030, 1,029. So there's a little sidebar on the rectangular model, which can be used to multiply by. So don't forget, if you have multiplication problems, you actually can put those in the form of a rectangle and partition your rectangle into smaller pieces to actually do those calculations. So it's just a different way of multiplying. Try it. You may find that to be kind of fun.